Welcome to Mathenatic. In this video, we'll discuss cofunctions and reductions of trig ratios on the Cartesian plane. Let us start in quadrant 1. In quadrant 1, our angle size would be between 0 and 90 degrees. And what we know is that all three trig ratios would give us positive results in quadrant 1. That means that sine theta, cos theta, and tan theta will give us positive answers if the angle size of theta is between 0 and 90 degrees. One of the other features in quadrant 1 is called a cofunction. So that is, if we start at 90 degrees and we move back by theta, what happens is that sine 90 minus theta would change to cosine of theta, and cos 90 minus theta would give us the same result as sine theta. Let's move on to quadrant 2. In quadrant 2, the angle size would be between 90 degrees and 180 degrees. What we know is that if the angle is between 90 and 180 degrees, that only sine theta will give us a positive result. That means that cos theta and tan theta in this angle size would give us negative results. Now let us look at the reductions and cofunctions. So if we start at 90 degrees and we move on by theta, if theta is an acute angle, then sine 90 plus theta would be equals to cosine of theta, and cosine of 90 plus theta will give us negative sine theta. And this is easy to remember, so we know that sine is positive if the angle size is between 90 and 180. And cosine in the same area is negative. So if you have cosine of 90 plus theta, that will give us a negative answer. The other reductions to remember is that if we have sine 180 degrees minus theta, that will give us sine theta. Cos of 180 degrees minus theta will give us negative sine theta because cosine is negative in this quadrant. And tan 180 degrees minus theta will give us negative tan theta because tan is also negative in quadrant 2. Let's focus on quadrant 3. In quadrant 3, our angle size would be between 180 degrees and 270 degrees. And tan in this quadrant would be the only ratio that gives us a positive answer. That means that sine and cosine would give us negative answers in the third quadrant. So let's look at the reduction in the third quadrant. See, if I have sine of 180 degrees plus theta, that will change into negative sine theta because sine is negative in quadrant 3. Cosine of 180 degrees plus theta will turn into negative cos theta because cosine is negative in this quadrant. And tan of 180 degrees plus theta would simply stay tan of theta. So what we do with reductions of 180 degrees minus theta and 180 degrees plus theta, we are learning how to rewrite these trigonometric ratios as acute angles. So that is where theta is between 0 and 90 degrees. So let us go on to quadrant 4. In quadrant 4, only cosine will give us a positive answer. So tan and sine in this quadrant would give us negative answers. So in quadrant 4, our angle size would be between 270 and 360 degrees. All right? Another thing that I want you to notice is that in quadrant 4, we also speak about negative theta. So we can either say 360 degrees minus theta. So we go all around, that is 360, and we go back by theta. Or we can just say negative theta. So let us look at our reductions. Sine of 360 minus theta or sine minus theta would both give us negative sine theta because sine is negative in this quadrant. Cos of 360 minus theta or cos of negative theta will give us cosine of theta, and those are positive ratios. And for tan in this quadrant, we'll have negative tan theta. So that's a quick overview of the cast diagram that we would use in trigonometry. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.